Hello everybody, and welcome to the first part of this section 2.8 notes having to do with the algebra of functions. And really when we say algebra of functions, it's just kind of a fancy terminology for saying that we're going to do operations, kind of these familiar operations that we've done before with numbers. It's possible to do them as well with functions. And so things like add, subtract, multiply, and divide, we can do those with functions. And then there's also something that we will learn a little bit later in this same lesson, is that there's another operation that we do with functions that is a new one. It's something that we do not do with numbers, and it's represented by a little circle like that one, and it's called composition. But first, I want to get into the first four operations that we see here, which are the familiar ones. And there's given, for your benefit, the formulas here for how we will do it, but really it's not particularly anything new. Really what we're introducing is a new notation. These kind of ways of writing them: f plus g, f minus g, f times g, and f divided by g. We have notations for them, and what they mean is the natural thing. For example, f plus g of x, where f plus g is basically being written as a function itself, kind of just one little unit there, and it has its own argument of x. That's just really a shorthand, as it were, for taking the function f of x and then adding to it the function g of x. And the same goes for subtraction, multiplication, and division. Really what we're dealing with is some version of shorthand, basically, for this notation. And we have a lot of examples here that we can take a look at, and maybe it will clarify any points that might not be clear about how to do these operations with functions. We've seen before this thing of just evaluating, for example, a function at a given value. And so f of negative 3, what we should do is we should take the function f of x. And I want to be very deliberate here to show how this example works, because we're getting ready to see something that a lot of times it's not that easy, where we're going to be plugging in something besides numbers. So if it's very customary and very natural and sort of like second nature just to plug in values, we want to make it just as easy and natural for us to plug in things like letters or expressions. And that's what we'll be doing with composition as well. But here, getting into this example, we want to plug in negative 3 for x. So basically we have in our function that x is being squared, and then we have a subtraction of 3 times of x, and then plus 1. And so now that we've figured out basically where x appears, these places in the function, we want to replace x by the number negative 3. So there should be a negative 3 here, and then also a negative 3 there. And now we will just perform these operations that we have. It goes negative 3 squared, which is 9, and then it goes minus, it's negative 3 times negative 3 actually, so that becomes plus 9, and then plus 1 more, and so 9 plus 9 is 18, and then plus 1 more, this will make 19. Now, what about if we wanted to find one of these, like I'm looking at number 5, I would like to take a look at this example, because there's a couple of different ways that we could think about this one, and I want to look at both ways. When you have this function f of f minus g of negative 8, basically what we're dealing with is we want to take f of negative 8 and then subtract g of negative 8. That would be one way of doing it. So we could just basically take negative 8, plug it into f, come up with some expression for this one, take negative 8, plug it into g, come up with an expression for this one, and then, or really a number, and then subtract them. So why don't we actually do that one? That will be the first way that we do it. So we're going to find f of negative 8 there, and then we're going to subtract g of negative 8, which is going to be there. And so f of negative 8, we want to have basically negative 8 and then squared, and then minus 3 times of negative 8, and then plus 1. And same for g, we're plugging in negative 8 into this expression for g that we have up there, so it will go square root of 8 minus x should be here, so minus negative 8 like this one. And so hopefully it's clear why I put negative 8 in those places. If it's not, I would direct you to refer to the previous example a bit and get it very much nailed down in your mind of how just to plug in a number into a function. And so we will have here for f of negative 8, we basically have negative 8 squared is 64, and then it's going minus 3 times of negative 8, so really that's the same thing, like plus 24, and then plus 1. That's f of negative 8 that we're working on, and then we're subtracting g of negative 8, which is going to go square root of 8. Basically, you see these minus a negative 8 goes plus 8, like this one. And then we can simplify a little bit. 64 plus 24 is 88, and then we have plus 1 more, so it goes 89, minus, and this one's going square root of 16, which is 4, so minus 4, which is 85. So that's very good. Now, another way that we could think about doing this one is that we could actually first find what is f minus g of x and come up with an expression for this one, and then after we've done it, plug in negative 8 for x. So for example, f minus g of x, it's going f of x, which is x squared minus 3x plus 1, and then we want to subtract g of x, which is this square root of 8 minus x. And since there's not much in the way of like terms over here, we can just write it basically without the parentheses, and we'll be done simplifying that one. So it would go x squared minus 3x plus 1 and minus square root of 8 minus x. This would be f minus g of x, and then we can find f minus g of negative 8 just by coming into this one, and we can now plug in negative 8 for x. And if you do it, you will see that you also get 85. It's just two different approaches to this one. Since there's no like terms here, it's not too beneficial to try it the second way over the first way necessarily. They're pretty equivalent, these two methods for us here. Just want to remind you that there are two ways to approach it. First, find the expression and then plug it in, or else, like we did it the first way, plug in negative 8 independently into f and g, and then evaluate at the end. But that does it for this little introduction for doing operations with functions here. I hope it was helpful, and we will pick up next talking about a very cool application of differences of functions. So let's catch you in the next one. Bye.